Well, hello there, distance learners. Answer the prompts below concerning the coordinates of the polygon melon given below. If you translate melon using the rule x comma y goes to x minus 32 comma y plus 90, what are the coordinates of melon prime? And describe the translation on melon in words. How did it move? Left, right, up, down, how much? Go ahead, give that a shot. I'll let you know when we're about to get going with the in-class learners so that you'll know when to pause. Yes?
Are they gonna have doing this equation written out, or is it gonna be like up, left?
Both. Both. Okay, let me just see if I can get a good angle here without revealing everybody. Yes.
Is this the translate button?
What?
Is this the translate
No,
button?
that's tangent. Let me see if I can find a good angle. I think this one's going to be good.
Xavier, this Saturday is the 104th anniversary of when Einstein let us all commemorate him for his work.
Yes. Yes, that will do. We'll take a cup of kind.
And Sherlock Munns are on the case.
Yay, I like it.
So this heinous crime.
Also, one of you's losing a wampum. If you look at the floor, one of you's losing a wampum. All right, everybody. Can I get you back up here in 5, 4, 3, 2, 1. That was a fun moment, though, because I saw that either Lucy or India, whereas a wampum had fallen out of their bag, and I said, hey, one of you guys is losing a wampum. And there was this second where they looked at me because they thought that I was somehow reprimanding them for something, and they were like, you can do that? Like, that would be crazy. Like, because I know that they're going to have it so that we can scan your ID and give you a wampum that way. It'd be funny if you could do that and take one away. Be like, give me your ID. And you're like, no. You like snatch the ID, like, boop. That's minus a wampum. You're like running away from me, being like, get back here. I have like a scanner, like, boop. I'm like, that would be so crazy. Like, that would be awful. Like a -1 wampum just walking down the hall. Hey, what's up? Boop. And like run away. All right. Come on up in 5, 4, 3, 2, 1. Okay. What are the coordinates of M prime, A prime, and Y prime? And I would like to get those from Danica. What are the coordinates of M prime, A prime, and Y prime?
The coordinates of M prime are -50, 107. The negative, no, the A prime is -36, 0, and Y prime is -32, -22.
And what was the other one?
-22.
-22. How many of us were able to get those just fine? How many of us were able to get those coordinates? Fantastic. How about L, O, and N prime? So L prime, what is L prime? And I would like to get that from India. Where is L prime? And O prime? And N prime. That didn't really fit, but you get the idea. All right. How many of us were able to get those results without too much difficulty? Fantastic. Yeah, it literally tells you what to do with those. Now, how would you describe that translation in words? Riley, how would you describe that translation in words? 32 left, 90 up. I agree. That's exactly right. McCall asked a great question. She asked, so on the skill check, are they going to give us directions like x comma y goes to x minus 32 comma y plus 90? Or are they going to give us directions like it goes left 32 and up 90? The truth is it could do either. It could do either to you. And by the way, this is a level 1. Like if you can do this stuff, that's a 1. So what's a level 2? Let's find out. Open up your planners to page 90. Happy St. Patrick's Day.
And a happy St. Patrick's
Hi, happy St. Patrick's Day. Hey, Pictionary, what's the Pictionary today? Keep going. Shamrock. It's Shamrock. Also, the Jeopardy. You know what's weird? Everyone on my first period knew this. Nobody in my second did. Whether St. Patrick was responsible or not, none are found naturally in Ireland. What are snakes? That's true. I liked how it's leprechauns. Someone said that. It's like, yeah, St. Patrick's a saint because he drove the leprechauns out of Ireland. That's why there aren't any there anymore. That's like, so you're sitting around like chasing Lucky for his Lucky Charms, like, they're always after me, Lucky Charms. And you're like, you know, Lucky, I'll bet you like St. Patrick's Day. And he's like, St. Patrick! Don't you speak his name to me. He drove all the leprechauns out of Ireland. Why do you think I have to work for General Mills? I used to be something. Now I'm just a paranoid leprechaun. Anyway, that got weird. So, all right, what's our first essential question? And I would love to get that from Ashley. What's our first essential question? How can I reflect objects? Around the coordinate plane. And what is our second essential question? And I would love to get that one from Ezra. What is the formal rule for that? Sweet. All right, let's go ahead and get started, guys. Underneath your warm up, got a pencil? Today's topic is reflections. I should do this in green for St. Patty's Day, shouldn't I? Reflections on the no. Reflections on the plane. It's true, but it's getting there. I have a couple of green blades. Reflections on the plane. Hey, now guys, I want to talk to you for a second, but here's what you're going to do while you're talking about this. I want you to make a coordinate plane that goes 12 each direction, please. 12 each direction, 12 up, 12 left, 12 down, 12 right. But while you're making that, I want you to have a conversation with your group about the following prompt. One of the most frequently looked up terms on YouTube is kitten mirror. Why? I want you guys to talk about it. Why, while you, hey, whoa, while you draw your coordinate plane that goes 12 every direction, discuss with your partners. Why is the term kitten mirror so frequently looked up on YouTube? Meow. Teach. 12 each way. Twelve. Okay, can I get you guys back up here in 5, 4, 3, 2, 1. All right, everybody, let's see how that went. Why is it so much fun to look at kittens interacting with mirrors? India?
They see their reflection and they get freaked out and then they're like sad at themselves, but it's the mirror.
Why? Why do they do this?
Because they don't know it's a reflection. They think it's another cat.
Yeah, exactly so. So in order to do this part without showing anybody's faces, I have to put this over here. So if you guys will turn around, Let me get the distance learners on here. Hi, guys. So, for example, if a kitten was looking at this mirror, ultimately what they're doing is they're walking around minding their own kitten business, and then they see this and they're like, ha! Who's that? I don't like that guy. I'm going to bristle up. You bristle up and like, woo! This guy wants to fight. I'll show him. I'm going to charge him. I'm going to charge him with my biggest charge. Whoa! That guy kind of looks like he's like, oh, wait a minute, he's backing off. I'm going to get, yeah, whoa. There's this weird thing where they think that the mirror is an actual other cat. And I want you to imagine, when I'm talking about reflections on the coordinate plane, we're going to live in that world where the reflection world is actually physically there. Yes, I know it's all in the mirror, but I want you to pretend that like I'm over here helping Jack. So anyway, I'm just helping you out with it. Whoa! Guys, there's this window over here. Have you guys ever seen this window? Where does this go? This is so crazy. What's through this window? What's in there? Whoa! There's a dude in there. And he looks just like me. Now, in the weird mirror world, guys, if I'm standing here looking at this guy, I'm standing, I don't know, 8 feet away from the mirror. How far away is that guy standing? He's 8 feet away from the mirror. Total is 16, but 8 feet away. I take a step forward. What does he do?
Take a step forward.
He takes a step towards me. I take a step back. If I take a step this way, which way does he go? He follows me, right? He follows me like this, but forward and back, he does the opposite. So, we're living in a world where we're going to feel like those people, the people in the mirror, are actually there, and we're going to graph what they are. No, we don't actually have any mirrors in our house that come down to the floor. Especially now that he's an older cat and he's just like, yikes! All right. Got a pencil? Let's graph the figure CAT. And C is going to be at 8, negative 5. A is going to be at 6, negative 3. And T is going to be at 4, negative 7. Let's go ahead and graph cat right on there. There's cat. Now, folks, I know that when I look into a mirror, because I am not a cat, I am a man, and when I look into a mirror, that I'm looking at a reflection of myself, and that the thing in the mirror totally exists on that flat piece, right? Like if I'm looking in a mirror, the whole of that existence, no, thank you. The whole of that existence is flat on that mirror. But it looks like I'm looking at a person who's standing like 3 feet away from, like 3 feet away from me, 1.5 feet from this mirror when I'm staring into it like that. So I want to know, guys, if the mirror that the cat is looking into is the x-axis. Show me with your arms which one's the x-axis. Yes. If it's looking in the x-axis, where does its reflection appear to be standing? Go ahead, guys. I want you to reflect cat over the x-axis. Give that a try and see how it goes. Teach! Distance learners, I'll be right back. I got to hand out some parchment paper. You might want to go get some too. What should we use? The parchment paper? What are you doing? A ruler? Or the mystery mouse tool?
The mystery mouse tool. It's a surprise tool that could help us later.
It's a good question. If this is the mirror, what does the reflection of the cat look like?
Who just said they never watched that show? You never watched Mickey Mouse Clubhouse?
Be right back, guys.
It's Mickey Mouse.
Okay, everybody.
I'm really tempted to grab those and start yelling at them just
Here
because
in
people.
5, 4, 3, 2, 1. Hey, so some of you guys may have figured this out already, but I want to show you how to do this with the parchment paper, which, by the way, how many of you found that the parchment paper and actually graphing this was kind of helpful this time around? Yeah, well, that's okay. I want to show you because, guys, I'm going to tell you right now, we're going to do a reflection later that it's going to be pretty hard to do without a parchment paper. So if you haven't already, got a parchment paper?
Absolutely.
And I want you to trace cat on it. Yes. And I like to label cat as well. Maybe it's act or tack or attic.
Tack.
Now, folks, when we reflect over something, really what we're doing is we're flipping the paper over the mirror. So what I like to do is I like to actually take a piece of my mirror, the easiest one's the origin, and if I flip it over the x-axis, it's going to flip over like this, and the mirror spot needs to land right back on itself like that. How many of us got a figure that looked something like this one? Something like this one?
Oh my
That's good.
goodness.
Excellent. And that's how we reflect things with that parchment paper. So let's go ahead and grab that.
I freaking hate these.
Everybody go ahead and grab cat prime. Graph cat prime and tell me the coordinates of cat prime. So when I say teach, you're going to say, okay. I have to turn off the camera. Yes, the reflection is cat prime. The reflection is cat prime. So graph cat prime and tell me the coordinates of cat prime. Give it a shot and teach. And getting caught in the rain? Did I hear that right? If you're not into yoga and you have half a brain? I actually can't finish that song. Well, clearly you do because you recognize it as 70s pop culture.
70s pop culture is
Okay, everybody. Can I get you back up here in 5, 4, 3, 2, 1. What are the coordinates of cat prime? Let me see if I can get a little help. Ashley, what are the coordinates of cat prime?
What I got was for C prime 8 comma 5, then 6 comma 3, and 4 comma 7.
Excellent. How many of us were able to get those coordinates there? Perfect. Now, I heard somebody say, oh, look, all you're doing is you're taking away the negatives, which it's true that that happened, but I'll tell you it's not as simple as just removing any negatives. And let me show you guys why that is. So I think the best way to do that is let's say that cat is looking at its reflection in cat prime, but we got an Alice in Wonderland situation going on, and cat prime is looking at its reflection, which is the mirror of the y-axis. Which one's the y-axis? The y-axis is the vertical axis. So I want you guys now to tell me what are the coordinates of cat double prime if I reflect cat prime over the y-axis. Go ahead, give it a try and teach. Reflect cat prime over the y-axis.
Are we going to reflect the reflection?
Yes. Yeah, so we're going to take cat, because otherwise it's hard to name. cat prime here, and then we need to take a piece of the, let's see, cat prime was right here, and then we're going to reflect it across the y-axis would be something like this. Right there.
Oh, wait a second. I did it wrong. What would it be? Would it still be prime?
Double prime. 2 primes.
Double
That would be
prime.
cat double prime. Double the prime, double the time. That's funny.
Find some weird trick that's gonna make us
Double the prime, double the fun, double transformations. That's just one, but actually 2.
I know. Xaxis. I just think that he's gonna like. Yeah, Mr. Peterson, you're gonna pull something out that's incredibly hard, aren't you? You're gonna be like,
So
go
the,
down.
on the x-axis,
Have
Maybe.
the reflection gets reflected by the
This
reflection.
is
That's
too
how.
suspiciously easy. It's not equal math.
That's what it does. The reflection got reflected by the reflection.
What would happen if there was like a line coming up and it reflected this?
Well, we probably need to draw just in case.
Crevices, maybe.
It is breaking math. Breaking math in a order.
Breaking that.
Have you seen pictures of this previously?
It also makes a cat. So.
It's like a ripoff of
Wait, it does?
Yeah.
Oh yeah. Mr. Peterson, it makes a cat.
Triangles make cat ears.
Aw, meow. All right, everybody, can I get you back in 5, 4, 3, 2, 1? Sam, what are the coordinates of cat double prime? What are the coordinates of cat double prime, Sam? Close. It's actually negative 6 comma 3. It's actually negative 6 comma 3. That's okay. It can be hard with parchment paper, I agree. But I'll bet you what, Sam. Now that you know that's negative 6 comma 3, you can probably see the pattern and tell me what C prime is. What is C prime? It is. Yes. How many of us are able to get those coordinates? So here's what we're going to do. But there's one more transformation that we're going to do to cat double prime to turn it into cat triple prime. But before we do, I want to know, guys, what appears to be the rule when you reflect something across the x-axis, and what appears to be the rule when you reflect something across the y-axis? That is, I want you to fill these in. Got a pencil?
Absolutely.
So reflection across the x-axis has the formal rule x comma y turns into something comma something. And on a similar note, reflection across the y-axis has the formal rule x comma y turns into something comma something. If you're not confident in your answer, you don't have to fill it in just yet. But I do want you to talk to each other. What do you think I'm going to put in those boxes? What happened when I reflected across the x-axis? What happened to the x value and what happened to the y value? When I reflect across the y-axis, what happens to the x value? What happens to the y value? Give it a try and let's see how. Oh, yes, Henry?
I think you messed up on the second reflection. I think you messed up the letters P and A.
I don't believe so. Oh, wait, on the first one I did. I messed up on this one.
Yeah.
And then I carried it along, and you guys let it happen. Did I get anything right? I got C right. My bad. Sorry, guys. And you know what? I want you guys to notice that I actually, what's interesting is I didn't actually mess up the coordinates over here. Those of you at home are probably really wondering what's going on because I know the rule already. I already know the rule, so I didn't even have to look at my graph to get the coordinates right. So that's great. Thank you so much, Henry. Will you guys talk to each other? What is the rule for reflection across the x-axis and what is the rule for reflection across the y-axis? Give it a shot. And here we go. Teach. Maybe for food truck later. Okay, everybody. Can I get you back up here in 5, 4, 3, 2, 1. Okay. Does anyone think they know what the rule would be for reflection across the x-axis? Ooh, let's see here. I got 4 hands. Johnny, what's your favorite animal? Probably a dog? Okay. Probablyadog. Danica, what is the rule for reflection across the x-axis?
Okay, I'm not sure.
That's okay.
But my guess is probably for the reflection across the x-axis, it goes from x comma y to x comma negative y.
Yes, that's exactly correct.
From the y-axis, x comma y, negative x comma y.
That's right. And I actually think of it less as negative and more like opposite, right? Because you'll notice that since the y values were negative on the original, they became positive when they got moved up to the top. Because so that is exactly right. That is exactly what those rules are. Yes, sir, Henry.
Can you possibly reflect diagonally?
Why, I'm so glad you asked. Got a pencil? Eh, 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 eh. Oh, no, hold on. Guys, this is actually a really good point. Reflections for now always occur across a line. There are ways to reflect objects over a point. That's pretty complicated. There are actually ways to reflect things over a circle, which is absolutely bananas and actually strikingly beautiful, but mathematically way more complicated than I want to get today. You're going to have 2 things to do. Got a pencil?
Absolutely.
First thing you're going to do, I want you to graph the line y equals 2 minus x. I want you to graph that line right there on your coordinate plane. See if you can remember how, and I'm going to graph it up here while you go. Teach, teach. Where do you start? Where do you go? That's exactly what we're about to do. Okay, everybody. Can I get you back up here in 5, 4, 3, 2, 1? So long story short, guys, the way you would graph that is you would do, you start at 2, down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1, and it goes like this. Now, guys, it wouldn't be Alice in Wonderland if the reflection of your cat's reflection wasn't passing through a mirror. So I want you to go ahead and use your parchment paper and see if you can draw cat triple prime after it gets reflected over the line y equals 2 minus x. Give it a shot. I'll walk around and then I'm going to come up to the board and do it. Give it a shot and here we go. Meow. Teach. I'll be back. Yes. Cat double prime over that line.
Wait, which T's stay the same?
Almost.
Wait, so I just reflected this.
I
That's all I have to say.
we supposed to do
One.
triple prime? I was doing quadruple prime. Oh, it's triple prime.
All right.
Oh.
Guys, India's doing this perfectly. Let me show you. So what she's done is she's traced cat double prime, which I've made nice and big so it's easier to see.
We're supposed to be doing double prime. I was doing
Yeah, it's
quadruple
okay. If you did the wrong one, it's no biggie. Now watch this, guys. If you're touching a mirror, like if this smartboard was a mirror and you walked up to it and you're like, hey buddy, good morning, high five, and you put your hand right here, what does it look like your hands are doing?
Touching.
It looks like they're touching, right? The palms of your hands are in the same place. It would be so sad if you were like, what's up, buddy, high five, and then your reflection was like, you embarrass us. Like, but now I want you to imagine, because this is really weird, is that imagine that it's actually coming through the mirror. Like if you imagined, guys, that you're having some kind of a nightmare, and this smartboard is actually a mirror, and I started to come out of the mirror like, and I was like hanging halfway out. What would it look like was behind me? Well, no, because I'm like, my legs are still back there.
Your back.
Yeah, my back and the back of my head. I would look like a terrible Petersen monster that uses 4 arms for legs, has 2 heads, and just scuttles down the hall being like, they're going the wrong way. Much less threatening is the other half of that, where it's 2 legs joined at the chest, just like, just like kick it over. Anyway.
Okay.
Here's what happens. The mirror itself gets mapped right back onto itself, so I'm going to make sure I grab a little piece of the mirror right here. So that when I flip over, you can put that mirror back where it was.
I have like a proper full-on reflection.
Exactly there.
I had a reflection from freaking Oregon.
It's kind of weird. Can I get you in 5, 4, 3, 2, mine's blown, 1. All right, let's black hole it. Okay, so it's kind of weird, but ultimately it goes like this. If I'm here, I'm about, like, if you look at how far away I am from the mirror, it's like I'm half a diagonal from the mirror, right? Which means I'd be half a diagonal on the other side. Here I'm 1, 2.5, half, 1.5, 2.5. 1, 2.5, half, 1.5, 2.5. So when you get flipped over something like a diagonal line like that, it gets a little bit weird. And if you look at the actual coordinates of those, I'll tell you right now, it turns out that if that line is y equals x or y equals negative x, the rule is simple. If it's anything else, like y equals negative x plus 3, or heaven help us, y equals 4x plus 5, the rule is kind of a holy terror. So that's how we reflect figures around the coordinate plane. The only rules you need to know are these 2. Everything else, every other reflection, will like if it's not over the x-axis or the y-axis, there will be a picture that goes with it. There will be a picture that goes with it. Yes, go ahead.
So how would you reflect cat?
Reflect cat prime?
Yeah, how would you reflect cat prime over the longitude?
Sure, that's just fine. In fact, that's actually a little bit easier. So if we go to, so the question is, how do we reflect cat prime over that? And what you would do is you could either use your parchment paper or count diagonals, right? Just like we were doing before. 1, 2, 3.5, half, 1.5, 2.5, 3.5. It should just be on the opposite side.
Wait, what counts as a half and what counts as a full?
Okay, so basically, guys, for what it's worth, as long as we keep these as long as the slope of these lines is 1, which it always will be in 8th and 7th grade, that it'll always be either a whole like diagonal or it'll be a half diagonal. I mean, we could count by square roots of 2, but that hurts my brain, right? So if we're counting from here, notice it's 1 box, 2 boxes, 3 boxes, 4 boxes, 5 boxes, and then a half a box to get to the mirror. Then I go half a box, 1, 2, 3, 4, 5. There's the other one. 1, 2, 3, 4.5, half, 1, 2, 3, 4.5. And that looks like it could be a reflection of that, doesn't it? Like that's the reflection over that line right there. You're going to notice that you're going to make lines that are, here comes a $10 word, perpendicular. perpendicular to your reflection. I'll tell you right now, if it's over a diagonal, you'll get a picture. If it's over the x-axis or the y-axis, you might get a picture, but you might have to just use the rule. There is a self-assessment tonight on this. Tomorrow we're moving on to rotations. Rotations. By the way, we just did a week of Math 8 this week. We've done a week of Math 8. And by Friday, we'll have done 2 weeks of it. That's good, guys. You guys are doing great. Thank you so much for your time, and we will see you on the floor.